Welcome back. In this lesson, we're going to look at frontal systems. A front is a type of air, so it's either cold or warm, it's either wet or dry, and it crashes or interacts with another type of air. So if you have two masses of air that are slamming together, you're going to normally have weather, some kind of a weather system, a weather event happen right there at that intersection. So if you've ever looked out the car window and seen a long line of clouds and you can see the front of that cloud, that's called a front. These are clouds that are growing above air that you can't see. They're slamming together. So cold air coming in where it was warm, or warm air coming in where it was cold, or some kind of a combination of different air masses colliding. That often will lead to weather. So we're going to look at some of the examples. Okay, one of the most important upper atmosphere winds is the jet stream. And this makes your head hurt. When you start seeing how it works, it's absolutely beautiful, but it is hard. If you remember that I said that you're going to have, whenever the ground is hot, you're going to have low pressure at the ground, and you're going to have high pressure in the air because the air rose. Okay, as the air rises, it bunches up air in the upper atmosphere. Whenever you have this air up in the upper atmosphere and the earth is also spinning, you end up with a very fast upper atmosphere beam of air. And you actually have two of these, north of the equator and south of the equator. You have a polar jet stream, and then you have a subtropical jet stream. Both of the places where the air went up into the atmosphere, that air, once it's moving, is going to move very, very quickly. And these are called the jet streams. And the jet stream is very, very important in moving our weather clouds, essentially. Anything that's going to precipitate. So the jet stream will determine whether there's high pressure or low pressure on the surface, and as such, it will determine as whether different fronts of warm air and cold air collide into each other. So where the position of the jet stream is determines really the weather at the moment. And you tend to have a type of a jet stream in one time of the year and a different type of jet stream in the other. So generally, you can have, say, one season might have more precipitation than another, or more might be drier than another. It depends on where the jet stream is. A positioned jet stream can cause droughts. A positioned jet stream can cause way more water than normal and cause flooding. So a lot of the severe weather events can be attributed back to where the jet stream was and where the clouds with water are allowed to go. Right under the jet stream is where air is rising into the air. And when air is rising up in altitude and it cools off, you can end up with lots of clouds for that reason. So you can have storms or weather systems that form along these areas that under the jet stream. And we're going to look at what a front is. A front is when one type of air mass collides with or interacts with another type of air mass. So remember, there's different temperatures of air masses. There's polar ones and there's tropical ones. There's ones that are wet, maritime ones. There's ones that are dry, continental ones. So they have different amounts of temperature, different amounts of humidity in them. And as they interact, different things can happen. And that is really a study of weather, is the study of front systems. So let's look at the first one. The first front system is a cold front. Now, they're named after the approaching air. So a cold front is cold and warm air slamming into each other. And if it's called a cold front, then the cold is moving. So you think of warm air in an area and cold air coming into the area. All right. Now, the cold air is always going to want to stay close to the ground because it's dense, so it stays close to the ground. So usually you have kind of a little pinched off part of cold air, trying to get as close to the ground as possible, and the warm air sitting up on top of it. So the warm air is in a place, the cold air comes in, and a lot of times that drives that wet, warm air up into the atmosphere, and you're going to get a cumulus cloud. Normally, it's a cold front that causes thunderclouds or storm clouds. The next one is a warm front, and a warm front is exactly the opposite. Cold air is there, warm is moving, and the warm air simply rides up the wedge of the cold air. The cold air stays against the ground, and the warm air just continues to approach it, and so the warm air is driven higher and higher and higher, and as that warm air higher and higher and higher, you're going to get clouds also. Both of these normally would cause precipitation. As that warm air that has lots of water in it goes high up in the atmosphere and gets cold, it's going to condense, and that condensation is going to fall out as rain or snow. Another type of front that's kind of cool is called a stationary front. And if you're stationed somewhere, you don't move. So if it's stationary and you're standing there, what's happening is that the warm front is approaching, the cold front is approaching in the opposite direction. And it's almost like a tug of war where it's like a arm wrestling, where both of them are trying to advance and neither are doing a very good job. You're going to get some system form over that, a cloud system over top of that stationary front. And then another type of front is called the occluded front. And an occluded front is, what's happening is you've got a cold front. Let me stop again. You're going to have cold air. Then you have a warm front. So in your mind, what does that mean? The warm air is approaching. So the warm air simply climbs over the cold air, and you end up with a wedge where the cold air is on the ground and the warm air is above it. Now, while that was happening, while you had a warm front, you now have another type of air crowding it. So this is a 3-car crash. You had cold air, warm air approach it, and so the warm air climbed up on top of it, and you end up with a wedge, and then cold air is attacking it. So cold air is coming on top of a warm air. So you're ending up with 3 types of air, 2 colds on the bottom, and warm air trapped on top of it, and the warm air is encountering the cold air on both sides. So you end up with a cold front type cloud system where you have the big high storm cloud, but you also have the warm front storm system where you have the long stratus clouds over a long area. So both of those would be, both of them independently would be a weather event, and together they're even worse. Now, the last thing for this lesson is pressure. If you ever watch the water go down the drain in the bathtub, you're going to get a twirl. You're going to get a curve, because what's happening is that the water used to be there and now it's gone. And because it's gone, it's left a void that's being replaced by the water that's falling into it. So it's very much like wind. It's happening in the water, but it happens exactly like wind, where you have low pressure, and high pressure moves towards low. Well, as a result of that water trying to hit at low pressure all the time, the high pressure going to the low pressure, you end up with a circle. And if you've ever watched the water go down the drain, it'll always go in a whirlpool. You'll get a whirlpool, and you do this in wind as well. Air is a fluid. It flows. Water is also a fluid. It flows. So they act in very similar ways. So the same way that you're going to get a low pressure in the drain and you're going to get a circle around it, that'll happen in the air as well. So when you have a low pressure, normally the water in the case of a bathtub or the air in case of a storm will go counterclockwise around it. Okay, counterclockwise. If a high pressure, it's going to be opposite. I think of it using my right hand. I put my thumb up, that's the direction of the wind going, or the air rising, and then the pressure will be my fingers. So the fingers are going around. If you raise your right hand and stick your thumb up in the air, and that's the air rising, the pressure lines will be your fingers curving around it. So in the case of the bathtub, you're going to have counterclockwise water go down the drain. Okay, that's pretty cool. And it's exactly the opposite when you have a high pressure. The high pressure is going to be your right hand with thumb down, because that's the air going down towards the ground. That's why it's high pressure. It's bunched up on the ground, and your fingers are going in the opposite direction. So that would be clockwise. You're going to get a clockwise circle of air around a high pressure. You're going to get a counterclockwise circle of air around a low pressure.